Hey everybody, sorry, my video. Hey everybody, here's the key for the homework. I tried to like keep a name to a face during quarantine last year, so I tried to start my video each day with like my camera on, and then I turned it off when I started teaching. So you might see.
The person that you were going to like make an egg eater.
No. But all those like, you know how we had to like conference from like 8 to 9 in the morning? Like I had my computer up and it was just like optional if you wanted to come in and ask questions. So I had my computer up and I'd be like making my kids breakfast with like one headphone and like, oh, hold on. Eat your breakfast. You know, kids would be like, what? What are you talking about? Okay, sorry, back to number 6 here. The owner of a bookstore developed a model for determining the price of rare comic books. The price P varies directly with the number of people N, and inversely as the number of books in existence, M. So there's my equation. Anything direct goes on top, anything inverse goes on bottom. Now the next sentence says, if N people, which was 10, with 10,000 copies, and the price is $5, solve for K. Okay, so just cancel out a 0. And then we would have 1,000 on the bottom, so multiply over to the other side. So 5,000 is my K value. Or we could have just multiplied by 10,000 and divided by 10, but you get 5,000 either way. So 5,000 is my K value, then find P. So 5,000 N over M. So find P when N is 200. 5,000 times 200, all divided by 100 copies. So we just can cancel a couple of zeros out there. So 5,000 times 10, it looks like 10,000. Make sense? What other questions do we have? Either side. Out of that? Yeah. Number 3. So we got x squared minus x to the third all over 2x squared minus 5x plus 3. All right, let me see if they pulled out a negative. Okay, so I'm going to rewrite it in standard form on the top, which would get me negative x to the third plus x squared, all divided by 2x squared minus 5x plus 3. And then factor out a negative x squared, which would be x minus 1 on the top. Yeah. And then we have to factor the bottom. So 2x squared minus 5x plus 3 would turn into 6. So negative 2 times negative 3. Those are the factors that work there. So 2x squared minus 2x minus 3x plus 3. Okay, just make sure that works. So we pull out a 2x, leaving an x minus 1. Pull out a negative 3, leaving an x minus 1. So 2x minus 3, x minus 1 is the factorization. So 2x minus 3, x minus 1, negative x squared over 2x minus 3. Yeah. Does that make sense? And then when you go for what x cannot be, remember you look at your denominator. They say, yeah, good. I want to make sure that they're using both there. X cannot be 1, x cannot be 3 halves. Right, out of the 3 divided by 2. What other questions do we have? Yeah, go ahead.
When you do the numerator of 4?
The numerator of 4? Like factoring down the numerator of 4? Yeah. So we had x to the third plus x squared minus 20x. So factor out the GCF of an x, leaving an x squared plus x minus 20, which that's an easy type. So that's negative 4, positive 5. So x minus 4, x plus 5. Does that make sense? For number 4, right? Well, the denominator is, oh, they multiplied in, I would have left it like that. Yeah, is that what you had? Yeah, they just multiplied in the x. I don't know why they did that. You don't have to do that. Any other questions on the worksheet, front or back? Yes, sir.
We did 12 on the back.
Yep. The solve, check your solution?
Yeah.
Yeah, is that a, oh, they both must be solutions. You know, right before I start number 12 or number 11, you know, can you tell me what values of x would be undefined for, let's say, 12? Well, I guess I shouldn't say 12 right off that. Looking at 11, what value of x, if I get x equals that number, would I have no solution? 3, right? If I got x equals 3, I know I would have to throw that solution out. It's not as easy to see on number 12. So let's factor it down. 2x squared plus 8x minus 10 over 2x squared plus 14x plus 12. You wanted 12, right?
Yeah.
Okay, thank you. All right, so looks like I can factor out, ooh, looks like I can take out a GCF of 2 on both numerator and denominator. And that would make up my life kind of easier. X squared plus 4x minus 5, x squared plus 7x plus 10. All right, so that'll cancel out with the 2's. So that'll leave me with an x, okay, factors of -5 that I had to get to positive 4. Positive 5, -1, factors of 10 that'll add to get to 7, positive 5, positive 2. Canceling the 5s, so that'll give me an x minus 1 over x plus 2 is equal to 4. And then what I can do here is just multiply the x plus 2 over to the other side. So I've got an x minus 1 is equal to 4 times the whole denominator, x plus 2, which is 4x plus 8. Add the, whoops, sorry. Yeah, I'll subtract the x. So -1 is equal to 3x plus 8. Subtract the 8, -9 is equal to 3x. So -3 is equal to x. Can x be -3? Yes. Because if I go back to my denominator, the only things that x could not be were -5 or -2. If I got -5 or -2 as my solution, I'd say no solution. But I can have -3, so that's why -3 is mine. All right, any other questions on the homework that we want to talk through? Okay, let's get to our notes then for today. So I think we would all agree that if I asked you about fractions, numerical fractions, and I asked you what was more difficult, to multiply or divide or to add or subtract, you would probably tell me to add or subtract, right? The same thing is going to be true with rational functions, rational expressions. Adding and subtracting is more difficult than multiplying and dividing for the sole reason of you have to get a common denominator. Now, let's try to think back to what I was trying to get you to wrap your mind around when we had just numerical fractions. When you look for the LCD, because these are polynomials, you're not going to have the option of just kind of like intuitively knowing what the LCD is going to be. So because these are polynomials, what you're going to be looking for is the combination of all the factors. You're looking for all the common factors together, but you're not going to rewrite any common factors, okay? So let's take a look here. Adding or subtracting rational expressions is very similar to adding and subtracting fractions. Take a look at this example down below here, right? This is like the best case scenario, right? For fractions, when you've already got a pre-common denominator, when your denominator is already set up for you, like 1/5 plus 3/5. What I'm emphasizing here is that we understand, this is like a very, very simple idea with numerical fractions, but when we start putting polynomials in the mix, you guys do funky things. Like, what I mean here is that, look at the denominators. Do the denominators ever change when you have, once you get your common denominator? No, it's not like multiplication where you multiply through on the bottom. It's not like I'm going to add through on the bottom. No, the denominator is just the answer. Very, very common mistake is to try to add together your denominators. No, don't do that. Once you get your common denominator, that's the denominator of your answer as well, whether you're adding or subtracting. So likewise here, you see how I have common denominators? Perfect, awesome, simple, easy problem here. Well, that would just mean that I add together the numerator and keep the common denominator. So I've got x plus x, or 2x, -3 plus -2, -5. See, I would at this point need to try to factor down any possible answer. But because 2x minus 5 does not factor, I leave it as 2x minus 5 over x plus 4. Okay. Now, it says identify any x values for which the expression is undefined. So what's the only x value that this expression is undefined? -4. You look at the denominator for that, and you say, okay, x can never make the denominator 0. So therefore, x cannot be -4. So 2x minus 5 over x plus 4. X cannot be -4. Quite simple, easy example there. So let's take a look at a subtraction one. Do you notice how, again, I have common denominators already? Perfect. So keep your common denominator. Don't try to make it like 2x squared plus 2. It's just x squared plus 1. Now be careful here. When you go to subtract, you have to treat it like this binomial on the right side is in parentheses. So like this is going to be 3x minus 6x, or -3x. -4 minus 1, right? Not plus 1, but minus 1. -4 minus 1, so -5. Okay. So I have -3x minus 5 over x squared plus 1. Does -3x minus 5 factor at all? No. Does x squared plus 1 factor? No. So I'm done. X squared plus 1 does not factor. So there's my answer. So let's take a look at what x cannot be. Not 0. Anybody want to take a guess? Not nothing. What can x not be? 30. It could be 37. Because you can take 37 squared plus 1. It's a real number. Ah, yes, it's I. It's I. You say the denominator, x squared plus 1 cannot be 0, right? So you're basically solving that little equation. Sorry, I didn't mean to yell at you like that. Ah. All right, we square rooted it. We should say plus or minus I, but you're correct in that it's an I. Ooh, not equal to. Be careful with that. You can still solve that. It doesn't say identify any x values for which any real x values. It just says any x values, real or non-real. Okay. Now, let's think back to numerical fractions. To add rational expressions with unlike denominators, we rewrite both expressions with the LCD. Now, we have to be very particular about how we get our LCD. Like, for example, if I'm looking at 6 and 10, intuitively, what do you guys think your LCD should be? Don't say 60, that's not least. 30. 30 is my LCD. How do you get 30? Well, in my mind, here's what happens, and this is what I would like, and this is what I try to encourage you to do. I try to take, okay, the prime factorization of 6 is 2 times 3. The prime factorization of 10 is 2 times 5, right? So my LCD is going to be, well, you have to have all factors represented. We understand that the LCD has to be a factor of one of the numbers, right? So it must include all of the factors of one of the numbers. Like 6 here, 2 times 3 has got to be included in there because it's got to be a factor of 6. And then I look at my other number and I say, okay, well, if it's 2 times 5, I've already got a 2 written there. So all I need to include is the prime factor of 5. 2 times 3 times 5 is 30, right? But what I'm focused on is this piece right here, because that's the same process that we're going to do when we try to find the LCD of polynomials. We factor it completely down and then write out all of our factors, and we're not going to rewrite any factors. Okay, we're not going to rewrite any factors. Like, for example, here, I say, okay, well, this is 2 times 3 times 5 is my LCD. Now, 30 is my LCD, and then I think about this. Well, 6 is really 2 times 3, and 10 is really 2 times 5. So all I have to do is multiply both numerator and denominator by my missing factor. Multiply both numerator and denominator by my missing factor. My missing factor out of the LCD is 5. So I multiply numerator and denominator both by 5. My missing factor here out of 10 is 3. So I multiply numerator and denominator by 3. That's the process that I'd like you to think about. Take your LCD and multiply both numerator and denominator by all the missing factors to make it work out. Like in this one, it just turns out to be 10 30ths plus 9 30ths or 19 30ths. Then you'd have to remove any common factors in the end, right? But this one, they're both prime, or no, 19's prime, so you don't remove any factors. All right, so let's practice that here. I've got x minus 3 over x squared plus 3x minus 4 plus 2x over x plus 4. We notice that these are unlike denominators, so I can't go right ahead and add. So what do I have to do? Well, I have to look at both of my denominators and factor down both of my denominators. So I'm just going to start rewriting the problem. I've got x minus 3 over the factored version of its denominator. Right? Looking at the prime factorization of each denominator. Factors of negative 4 that have to get to positive 3 are positive 4 and negative 1. The right side is fully factored down. Every time we do one of these problems, I would like you to list out what your LCD is. Okay, so that means my LCD is going to be, okay, it's got to include all of this one here. X plus 4, x minus 1. Then look, do I have to add in any factors? No, because the x plus 4 is already there. The x plus 4 is already there. So I don't need to like rewrite it again. I don't need to have like an x plus 4, x minus 1, x plus 4. Now the x plus 4 is already there. So that's my full LCD. So what I would encourage you to do is start to make a new line and say, okay, well, if that's my LCD, this is what this should look like. Right? It should be the same denominator throughout. Now, do I need to multiply anything into my left piece? No, because it has the full common denominator. So you're going to leave it exactly the same. You're not going to change that at all. It's just an x minus 3. It's going to stay an x minus 3. What's the missing factor here out of my right side? The x minus 1. So the missing factor is an x minus 1, so I've got to multiply by x minus 1 over x minus 1, which gets me, multiply in here, 2x squared minus 2x. Yeah, you do factor that. You do FOIL that, multiply it in, distribute it, whatever you want to call it. Because in the end here, watch what's going to happen. I have x and negative 2. I got a 2x squared. X plus negative 2x is a negative x. And then a negative 3 plus nothing is a negative 3. And now I have to look and see if this is factorable. Okay, because I have to see if there's any common factors within 2x squared minus 3x minus, or sorry, 2x squared minus x minus 3. Got to see if I can reduce that down at all. So let's check it. 2x squared minus x minus 3. Okay, factors of negative 6 that add to get to negative 1. Negative 3 times 2. Right? So 2x squared minus 3x plus 2x minus 3. So that means I factor out an x, leaving a 2x minus 3. I factor out a 1, leaving a 2x minus 3. So it's 2x minus 3, x plus 1. All right, so that reduces down into 2x minus 3, x plus 1. And it's very tempting, but can I cancel anything? I wish I could cancel that plus 1, minus 1, but I can't. So you just leave it like that. Questions about that? Yes, sir. Could I cancel if it was x plus 1? Yes. Yeah. Oh, thank you. Yep, identify any x values for which the expression isn't fine. So what you basically can do here, it's kind of like, you have to look at all denominators and see where the expression is undefined, but there's a shortcut to that. If you've already found your LCD, doesn't that contain all of the factors of any denominator that you would have had? So what you can do here is you just basically set your LCD, you set your LCD not equal to 0. So basically x plus 4, x minus 1 not equal to 0. So you can say x not equal to negative 4 or positive 1. Okay? Again, when you're adding and subtracting, when you create your LCD, you're basically compiling all of the prime factors of any denominator that you would have had. So all you need to do is just set those not equal to 0. Okay. Let's do another one. Got 3x over 2x minus 2, 3x minus 2 over 3x minus 3. All right, so let's take a look here and factor everything down. I don't want to factor down numerators. Please don't try to factor down any numerators. I can't factor any numerators here anyway. But what I'm getting at there is you're eventually going to need to add or subtract them together. So why factor them down? You're not going to be able to add or subtract with things that are factored down. You're going to have to multiply it back together to add or subtract it. So that gives me a 3x over 2x minus 1 plus 3x minus 2 over 3x minus 1. So my LCD here is, okay, it's got to include all of my first fraction denominator, 2, and then an x minus 1. And notice how I leave a little bit of room, because what's the only missing factor out of my LCD? The 3. That's my LCD. Okay. So now I can rewrite it like this. I can say, sure, 6 x minus 1 plus 6 x minus 1 is equal to 6 x minus 1. Okay, I look at my left side fraction. The only thing missing out of that is my 3. So I multiply it on top to get a 9x. The only thing missing out of my denominator on the right side is my 2. So I multiply top to bottom, I get a 6x minus 4 when I distribute it. 9x plus 6x is 15x. And then minus 4. And that doesn't factor, does it? And then x cannot equal, well, remember that x cannot equal just, like you're just looking for x values. Do I want to say x is not equal to 2 or x is not equal to 3? No. Those are just constants sitting on the bottom. You only look at what x values cannot be 0. So x cannot be 1. That's it. I don't care about the 2 or the 3 or whatever, the 6 sitting down there on the bottom. No, it's just a constant. Okay, questions about that? Keep it moving. Let's subtract a little bit. 2x squared minus 30 over x squared minus 9 minus x plus 3, or sorry, x plus 5 over x plus 3. Okay, first thing I've got to do is factor everything down. Factor all denominators down. See, do you notice how they could pull out a 2 on the top left side? Don't do that. You don't need to. You're going to subtract with it eventually, so why factor it down? So 2x squared minus 30 over x minus 3x plus 3 minus x plus 5. I don't know why I put that in parentheses. That's okay. Same thing. So my LCD is just x minus 3x plus 3. I don't need to change the left side at all because it includes both factors out of my LCD. So 2x squared minus 30 over x minus 3x plus 3 minus something over x minus 3 x plus 3 equals something over x minus 3 x plus 3. And now I have to multiply in my missing piece out of my common denominator. So I'm going to multiply by x minus 3 over x minus 3. So which gets me, now I have to FOIL the numerator. I have to FOIL the numerator. First, x squared. My outer would be negative 3x. My inner would be positive 5x. So all in total, positive 2x. And then 5 times negative 3 is a negative 15. And now I take 2x squared minus x squared to get x squared. Watch here. Everybody eyes up here real quick because this is going to be a very, very, very common mistake. What should my 2x be, positive or negative? Should be negative. A lot of people would miss that, make it positive. Nothing minus 2x. Minus 2x. And then I've got negative 30 minus a negative 15. Another one here. Negative 30 minus a negative. Minus a negative is going to turn that plus a positive. So negative 30 plus 15 is a negative 15. Not negative 45. Negative 15. And now I factor it down. I factored that down. That's an x minus 5x plus 3. Yeah. Leaving an x minus 3x plus 3 on the bottom, which will cancel with the x plus 3's. So x minus 5 over x minus 3 is my final answer. As well as, what can x not equal? Yeah, 3 or negative 3, or plus or minus 3 if you wanted to say it that way too. Questions about that? All right, the last thing that we're going to talk about within section 8.3 is what's called a complex fraction. Now, just because you see the words complex doesn't necessarily mean it's non-real. Complex in this just refers to the fact that it's kind of a fraction within a fraction, like a difficult one, not like a non-real one. Some rational expressions are complex fractions. A complex fraction contains one or more fractions in its numerator, its denominator, or quite possibly both. These are examples of complex fractions here. Basically, a fraction within a fraction. Okay, a fraction within a fraction, and we can try to simplify it as best as possible. Like here, you see how there's a fraction in the denominator of another fraction. There's a fraction in the numerator of another fraction. There's a fraction in both numerator and denominator of that fraction. Okay. Now remember that the big fraction bar in the middle is really just a division sign. So what we could do is we could treat it as division and then keep change flip and try to manipulate it as best as possible. Okay? So let's try it. Let's take a look here. Now we are going to, this is important that you see this here. Assume that all expressions are defined. This is another one of those ones where if I dive down the rabbit hole of trying to figure out what could be undefined, since I'm doing division, I have to think about not only what should be undefined in each of the little denominators on the top and the bottom, but also think about what would make this whole denominator equal to 0, because that is also a denominator. So we're just going to assume that all expressions are defined. We're not going to identify anything that would make it undefined. So how do we simplify this down? Well, in my opinion, it would be best to just write it as a division problem. Like here, this would be x plus 1 over x squared minus 1 divided by x over x minus 1, right? That's really what that fraction bar is saying. And we can do a division problem with fractions. No big deal. Let's factor it down a little bit. So that would be x plus 1 over x minus 1, x plus 1. Keep, change, flip. And now we can act really smart, cross a bunch of things out. Minus 1, plus 1, plus 1. What's this going to equal? 1 over x, not just x. I always have a small percentage of people trying to just like let that float up to the numerator. If it's in the denominator, it has to stay in the denominator. If everything cancels out in the numerator, you have to write a 1 in the numerator. So 1 over x is my answer. That whole big nasty thing simplifies down to 1 over x. Yes, sir.
Why couldn't you move it to the numerator? Wouldn't that make the x negative? So it could be like negative x.
Ooh, you're thinking of x to the negative 1.
Yeah.
Yeah, I guess. Yeah, but it's not technically good form to leave a negative exponent. So you're right. We could make it x to the negative first power. But we'll leave it as 1 over x. And let's do one more. And this is where it starts to get a little bit more funky, because I see not only a fraction within a fraction, but I see a fraction that I need to add together within another fraction. Let me remind you that this fraction bar is a big grouping symbol. So basically, I have to reduce down the top by whatever means necessary. Then, at only that point, can I divide by whatever's on the bottom. See, I've got to reduce down the numerator first before I keep, change, flip. What do I mean by that? Well, what's my LCD of the numerator pieces? 2x. Right, 2x. So my LCD here is 2x, which means I need to get the 2 over 2 here. Right, so that means I've got a 2 over 2x plus 1 over 2x. And then we can add that together. So 3 over 2x. I'll start keep, change, flip now. Keep, change, flip. Nothing cancels? That's a bummer. That's okay. So we're going to have 3x minus 2, 2x, x plus 4. You don't need to multiply that together. We can leave it like that. Questions there? Okay. Let me put up the homework page. I think I have like 9 minutes. I'll throw that up there for you. Oh, I've been bad about turning off my videos. Past couple of times, like I was teaching algebra, I forgot, and then I like recorded 10 minutes in a calc. That's no good.